Okay, this is angles at a point. Our essential question is, how do I solve for missing information using the properties of angles at a point? Angles at a point add up to 360 degrees. So that means that from this diagram, A plus B plus C equals 360 degrees. So let's look at number one. We're solving for the value of x. So our justification, these are angles at a point. This is the point. This angle out here is the 226. Here's our 27. And here's our x. So I should be able to say that x plus 27 plus 226 equals 360. That becomes x plus 253 by combining like terms equals 360. Subtract 253 from both sides, and I get x equals 107. That's all it is. The justification, our equation, and our solution. Sometimes the problems can have more than 3 angles. So again, we're looking for x this time. Our justification is angles at a point. So I can say that x plus 41 plus 36 plus 120 equals 360. I usually go in order some way, clockwise or counterclockwise, just so that I don't miss one when I'm going through them. So that's 197 plus x equals 360 by combining like terms. Subtract 197 from both sides. X equals 163. So angles are a point. Here's our point. They form a circle, right? So 360. As we go around the point, we come all the way back. So we start with angle X, and we go all the way around to start at angle X, and we go all the way around, and we get to the other 220, then we've made a full circle, and so that's why it's 360 degrees. Let's look at number 3. This time, we are finding the value of x and solving for missing angles. So there's 2 parts to this. So we follow the same 4 steps that we have been for this section. Our justification is these are angles at a point. And I know that because all the angles have a common vertex. Right there. So then I write my equation. So I have x plus x minus 30 plus, what is this thing? This is a right angle, which means this is 90 plus 90 equals 360. So then I combine like terms, 2x, and then I combine those. Negative 3x and 90 is plus 60 equals 360. Subtract 60 from both sides. 2x equals 300 divide x equals 150. So that's solving for x. We're not done though. We have to do one more piece. So x is 150, so we've done that. But then x minus 30 equals 150 minus 30 equals 120. And of course we had x equals 150. So there I have both my angles. A couple more examples. So, justification first, angles at a point. That means I can write the equation x plus 2x plus 150 plus 4x equals 360. Combine like terms, 1 plus 2 is 3, plus 4 is 7x, plus 150 equals 360. Subtract 150 from both sides. 7x equals 210. Divide x equals 30. Now our question said to find the value of x and the missing angles. So there's x. So then we need to, so that means that x equals 30. 2x equals 2 times 30, which is 60. And 4x equals 4 times 30, which is 120. The last problem uses several of the properties that we've talked about first before this. So let's start with looking for other relationships. And if you look at angle Y, it is vertical with 82. So I still have to write justifications. So I'm going to put vertical angles. Y equals 82 degrees. So this one's 82. And then I can use supplementary angles. And say that 82 plus x plus 82 equals 180, because they're supplementary. So that's x plus 164 equals 180 minus 164 x equals 16 degrees. So this is 16 degrees up here. I just like to label my pictures as well. And then I can say that, again, using vertical angles, that z equals x, which is 16 degrees. So you can see how all those angle pairs work. Okay. So as you can see from that last example, we had to use a couple different properties to be able to find all the pieces in that angles at a point. I could, if I wanted to, find this last piece over here. I don't need this one, but if I wanted to, then I could use angles at a point, because now I have all the other measurements, and I could use angles at a point to find that last piece if I needed to. So remember, angles at a point all have a common vertex, and they equal 360 degrees.